Hello ladies and gentlemen. Today we will be doing Pre-Calc Lesson 12, Angles and Diagonals in Polygons, and we will be talking about our chord-tangent theorem. Let's start with angles in polygons. In all polygons, the number of sides is the number of vertices. So a polygon is a shape with multiple sides, okay? And vertices is like our corners. So in a triangle, we have 3 sides and we have 3 corners. Okay, and we also know that the sum of angles at any vertex is 360 degrees. Now, what does that mean? That means if I look at this vertex, and I'm to look at all around it, it's 360 degrees. Okay, and we know this by there is one angle inside and one angle outside. Again, in the picture I've shown here, we have an angle inside here, and the rest is the angle outside. Now, we have convex polygons. And in convex polygons, there is an interior and exterior angle at each vertex. And likewise, the sum of all the exterior angles is 360 degrees. Okay, so an example of a convex polygon is this right here. Okay, and we could say B, C, D, E. It's still a polygon because the number of sides equals the number of vertices. Okay, and we know that at each angle we have both a inside and outside angle. Okay, now if I continued each of these lines, okay, I have exterior angles here and here, right? And I know that there's a straight angle made right there, D and E, which means that D plus E is 180. Okay, and that would be the same thing over there. Okay? Now, the other thing we can do for polygons, let's talk about the diagonals. Okay, now we have this fun thing we call triangulate, which means we draw triangles from the vertices, and we use this triangulation is used to find the sum of interior angles. So if I was to have this shape here, okay, this is my polygon, I can draw triangles from one vertice, key 1, right? I can draw it to each of my other, right here and here, leaving me with 3 triangles where the sum of each is 180. Right? And I can add up each of those and it would give me 180. Okay? Now, let me draw another polygon for you. Okay, if I had this and I had these exterior angles, to give you an idea, right? If I said this was 75, this is 100, 30, 40, 115. This is saying that the sum of exterior angles is 360, right? We can find the sum of our interior angles, okay? And this is the sum of our exterior angles. Now, we also have a formula for our number of diagonals. Because when we draw this, you think, how many diagonals can we draw? N times n minus 3 over 2, where we can say that n is the number of sides, or the number of vertices. Right? We've already said that that's the same. Number of sides equals number of vertices. Okay? And we also have a formula for the sum of interior angles. You can just solve for it using our triangulation, or you could say it is n minus 2 times 180. Okay, that gives us our interior angles, the sum of our interior angles. Okay? Now, let's do an example. In a 7-sided convex polygon, find the sum of interior angles and the sum of exterior angles. Okay, now I'm going to try and draw this for you. Okay, there is my 7-sided polygon. And we remember our formulas, right? The sum of interior angles, we know, is going to be n minus 2 times 180. Now, if I look at my triangulation, okay, I can draw my triangles here, 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 and here, leaving me with 1, 2, 3, 4, 5. Notice the number of triangles that I am able to draw is n minus 2. Okay, so n minus 2, if it's a 7-sided convex polygon, I'll have 7 minus 2 times 180, which gives me 5 times 180, which is 900 degrees. Sum of the interior angles. Now my exterior angles, the sum is 360. We already said that, right? The sum of all of the exterior angles is 360. Okay? All right, now let's talk about our chord-tangent theorem. Our chord-tangent theorem says that the measure of an angle formed by a chord and a tangent at the tangent's POC, point of contact. So the measure of the angle is equal to 1/2 the measure of the intercepted arc. Okay, very similar to inscribed angles. So let me draw that for you. We have the intersection of a chord and a tangent. Okay, and it's telling me that the measure of the angle formed here is 1/2 of the measure of the intercepted arc, which is here. Okay, this is my intercepted arc, here to here. Okay, now I'm going to do a quick proof for you of this. Okay, we have 3 different cases in this proof. I'm just going to do one. Often in proofs, there's multiple different facets you have to look at. A and C. Okay, now in this I have my chord and my tangent intersecting, okay? And I am finding that this tangent is going to be perpendicular to my radius, OA, okay? Therefore, the measure of angle BAC is 90, right? I have a right angle right there, okay? Now, I know that 90 degrees is going to be half of the measure of this arc, which means that arc is going to be 180, okay? So what my chord-tangent theorem says is the measure of angle BAC is 1/2 the measure of arc BXA. Now, if we're going to write an arc, we draw it with a little rainbow over it, okay? Now, I know that in a circle, if I have a diameter, that's the center of my circle, this is my diameter, okay? Then, therefore, since it's a diameter, I know that half of my circle is over here, half is over here, which tells me that this arc is 180. Okay? Therefore, we can just automatically say this is true because we know that 90 is 1/2 of 180. Yay. Okay? Now, let's do another portion of the proof. If I have this circle here, that's my diameter. That's my chord and my tangent. BA, this is C, Y, I have X. Now, I want to show, WTS, I want to show that the measure of angle BAC is 1/2 the measure of arc BXA. That's what we want to show. Okay? Now, we can see that BYA, I have an inscribed angle, and I know that the measure of angle BAY is 1/2 the measure of the arc BY. Okay? And I also know that we proved previously the measure of angle YAC is 1/2 the measure of arc YXA. Okay? Now, what I'm going to do is I'm going to add these together. So the measure of angle BAY plus the measure of angle YAC gives me 1/2 measure of BY plus 1/2 measure of arc YXA. Now, on this side, I can factor out a 1/2. So I have measure of angle BAY plus the measure of angle YAC is 1/2 times the measure of BY plus the measure of YXA. And I know that the measure of BY plus YXA, that's the measure of BXA. I also know that the measure of angle BAY and the measure of angle YAC is the measure of angle BAC. So therefore, my 3 dots mean therefore, the measure of angle BAC is 1/2 the measure of BXA, and we're done. That's kind of your end period of the sentence. Okay? Now, as always, if you have any questions, bring them to class tomorrow, and we will go over them, but that is all we have for this lesson.